Hello students, in the last session we have studied Java tokens. In today's session we will discuss data types in Java. You might have already studied about data types in C programming language. Java also supports the similar primitive data types. So let's start. Every variable in Java has a data type associated with it. Data type specifies the size and type of values that can be stored in the variables. Java language is rich in its data types. The variety of data types available allow the programmer to select the type appropriate to the needs of the application. Data types in Java under various categories have been shown in this diagram. Different data types, Java data types have been categorized into two different categories. These are primitive and non-primitive. Primitive data types are also called as intrinsic and non-primitive are called as derived. Even primitive types are called as built-in types and non-primitive are called as user-defined data types. In primitive data types, we have two subtypes. These are numeric and non-numeric. So in numeric, we have the types that is integer and floating point, whereas in non-numeric, we have the type that is character and Boolean. Non-primitive types are classes, interface, and arrays. In today's session, we will discuss only the primitive data types which are available in Java. The non-primitive types will be discussed in the later section. So primitive types, we'll start first with the first primitive type, that is integer. So integer type can be used to store whole numbers. For example, the number 5, 10, 20, 25. All these are whole numbers and these numbers can be stored in the variable of type integer. Integer type has different subtypes into it. So we have a type called as byte. The size of type byte, it is 1 byte, and the range of values which we can store in the byte variable, it is -128 to +127. The range is -128 to +127. So we can declare a byte variable. For example, we can simply use a data type byte. Java uses a similar declaration of variables like C programming. The syntax is the name of a data type and space the name of a variable. So we have a variable C and the type of this variable, it is byte. The values which we can store in C varies from -128 to +127. All Java data types are signed data types. In C we have two different types, that is signed int and unsigned int. But in Java, all integers are signed That simply means we can store both positive as well as negative numbers in integer variables. Okay, the second integer type, it is short, which takes 2 bytes. That means it takes 16 bits, and the values which we can store varies from -32,768 to +32,767. In case of integer, that is int, it takes 4 bytes, and we can have values approximately -2 million to +2 million. Whereas in case of long type, whenever you want to store a very large number, integer number, you can use a data type that is long, which takes 8 bytes, and the values which you can store approximately, that is -10 e to the power 18 and to plus e to the power 18. So these are different subtypes of type integer with different sizes. Okay, that's it about integer. The next type, it is floating point type. Floating point type can be used to store the real numbers, or you can say fractional numbers can be stored in floating point data type. You can store numbers like -2.5 or +27.59. So we can store these real numbers by using the type that is floating point type. So floating point type also has two different subtypes. The first is float, and the second type, it is double. So float has the size that is 4 bytes, and the values which can be stored in the type of float variable, it is -3.4 e to the power 38 to +3.4 e to the power 18. Then we have one more type, that is double. Whenever you want to create a variable which stores a high precision number, then you can go for a type that is double, which takes 8 bytes. The declaration of the floating point variable in Java, it is again similar to the declaration of a float variable in C program. So we simply declare a data type, that is float, and the variable name, say f. So this is how we can declare a floating point variable, and similar way we can declare even a double variable. Now one more important thing about this floating point which you have to note, it is floating point numbers are treated as double precision quantities. All floating point numbers, floating point constants are treated as double precision. You can say these numbers are treated as double numbers, and if you want to force them to be in single precision mode, we have to append f, small f or capital F to the end of a number. So if you are creating a variable of type float, and if you are storing some value into it, you have to append f, small f or capital F to the end of the number. Okay, let me show you this with an example here. Okay, let us type a simple program here. So I'll say demo. Public static void main. So this is our main function. It takes one argument, that is string argument. Inside this main, let me declare a float variable now. Float f. Let me assign some value to it. Let's say 1.5. And then I'll print the same. I'll say system.out.println. I'm printing the value which is stored in variable f. Let me close the main and class. So this is a simple program where we have declared a floating point variable and we are printing the same. So let me save it. As I told you, while saving your file, you have to save it with a class name. So class name here it is demo. So we will be storing it as, we will be saving it as demo.java. Okay, the program has been saved. Let me compile this program now. So I'll open cmd, compile the program. We have stored this in f, so I'll move to f by using a command, that is f:. Now I am in f drive. Okay, let us compile this by using a command javac space name of the file, that is demo.java. If you look at this, it is throwing an error. If you read the error carefully, it is saying incompatible types, possible lossy conversion from double to float. And this is very, very important here. As I've told you, all the floating point numbers are considered as double precision by default. So this 1.5 is considered as a double number by default, and we cannot store this double number into a floating point variable, that is f, and that is why it is throwing an error. If you want to convert this 1.5 into a single precision number, what you have to do is you have to append f at the end of a number. You can append capital or a small f, doesn't matter, but you have to append f at the end. And now if I save it and if I again try to compile the program, you can see there are no errors. And let me execute this java space 10, and you can see the output of it. So all the real numbers are considered as double precision by default. Remember this. If you want to store those real numbers into a floating variable, you have to append f at the end of a variable. Okay, this is about floating point type. The next type is character type. As the name suggests, character type can be used to store a single character. The character type in Java, unlike C, it takes 2 bytes. In C, character type takes a single byte, whereas in Java, character type takes 2 bytes, and the values which can be stored in the character type are all the symbols which are enclosed in single quotes. We may store alphabets from capital A to Z, small a to Z, numbers from 0 to 9, or any other symbols in the character type which is enclosed in single quote. We can declare a character variable in Java in a similar way like we declare a character variable in C. So we can declare it as char, then your variable name, let me say C. If you want to store a value into it, you can say equals to in single quote. So you have to enclose your values in single quote if you want to store it in the character variable. Say 0. So here we have declared a variable of type character having value 0, not numeric, but character 0 because it is enclosed in single quotes. So this is character type in Java. Next type Okay, some other examples like when you enclose 5 into single quote, it is considered as a character. Even the other values which can be stored in the character type. Okay, next type, it is Boolean type. Boolean type, it is used when we want to test a particular condition during the execution of the program. There are two values that a Boolean type can hold, and these values are true and false. If we have a Boolean variable, this Boolean variable can have only two values. It can have either true or false. So Boolean type is denoted by the keyword Boolean and uses only one bit of storage. So that storage space which is taken by the type Boolean, it is only 1 byte, remember. And the values which can be stored in Boolean type is either true or false. It can be declared in a similar way. We can say Boolean that is our type and space name of the variable, let us say b. So this is how we can declare a Boolean variable. Okay, that's it about data types in Java. In today's session we have discussed the primitive data types which are available in Java. Primitive data types are also called as built-in, which are provided by the language. We don't have to define these data types, whereas the user-defined data types like classes, interfaces, we need to define these types in the program. These non-primitive data types will be discussed in the later sections, and we'll stop here today. Thank you.